Okay, guys, I'm back and I am reviewing 1.7 and 1.8. I only chose one simple problem. Let me rearrange things here. I only chose one simple problem for 1 point for 1.7 just because I wanted you to be able to see me do a problem from that lesson. From 1.7, I'm going to do problem number 46. So doing problem number 46 from 1.7, and it looks like it is on page 30, and the directions just say simplify. So I'm going to solve number 46. So it's negative 1/2 plus 5/4 minus 1/3. Okay, so I want to kind of solve this for you and just sort of walk you through the easiest way to solve this. First, we are dealing with an addition problem. We're dealing with a fraction problem that contains addition and subtraction. This is an addition and subtraction fraction problem. So when you are adding or subtracting fractions, you must start with having a common denominator. If you do not have a common denominator, there's absolutely no way, denominator, that you can solve this problem. It's an impossibility. So I have to start with what is a number that can be divided by 2, 4, and 3 evenly? What denominator that would be common amongst them? And the denominator that I can come up with is a 12. So in order to find my common denominator, what I have to do is I'm going to go ahead and just throw in all these little 12s down here. My denominator is 12. And here's kind of how I figure it. Okay, 12 times what is, 2 times what is going to give me 12? Well, it's 6. So 2 times 6 gives me 12. Whatever I do to the bottom, I must also do to the top. So I must say 1 times 6 will give me 6. And it's very important that I realize this was a negative and I keep the negative intact. Okay, 1 down. So let's convert this one. 4 times what is going to get me to 12? Okay, 4 times 3. It's an even number, or it just solves out easily, so I could use 12. 4 times 3 gets me to 12. So I have to do the same number for 5. So 5 times 3 is 15. And I have to remember there was a plus sign here, so I have to keep my plus sign intact. Okay. So now I have a 1/3 and I'm trying to convert it to something over 12. Okay. 3 times what is going to get me to 12? 3 times 4 to 12, easy. So what I do to the denominator, I must do to the numerator. So I'll put a little times 4 right here. 4 times 1 is 4. And I must remember that I had this negative number or subtraction sign and keep it intact. Okay, so I'm going to go through and erase all this extra stuff, which is just crazy. It's everywhere. Okay, and I retained all my signs. So good, that worked out well. So now what I have is negative 6/12 plus 15/12 minus 4/12. So I think the absolute easiest way to do this is to put all of this business here on top into one swoop. So I'm going to say minus 6, negative 6, plus 15 minus 4. And I'm going to put all that over my common denominator, which is 12. Now, if I just do the math and I say, okay, I have a negative 6 and a positive 15, well, my greater value is 15 and it's positive. So if I say a negative 6 and a positive 15, I'm going to get a positive 9. So if I use a number line, I would end up with a positive 9. And then if I have a positive 9 and I take away 4, then I'm going to end up with 5. So my actual answer is 5/12. Now I was able to do all of this in my head because to me it's easier to sort of view it like a number line. Like I go to the negative 6 and then I'm like, oh, I'm going to go positive 15. So I'm going to be way over here now. I'm going to be to positive 9 and then I got to go back negative 4. So then that's going to put me at 5. I do it better viewing it as a timeline or a number line, but that doesn't work for everybody. So if it doesn't work for you, then you could do something called algebraic addition. Some people call it addition of the opposite, but algebraic addition would have you solve it like this. You would do -6 plus 15 minus 4. And so what they would want you to do is they would want you to do the addition of the opposite. And when you do this, the algebraic addition, you put all of your negatives in a parentheses like that. So you have a -6 in a parenthesis plus 15 plus a -4. And oftentimes when you do it this way, they'll recommend combining what's considered a like term. So here I have a like term of a -6 and a -4 that I could combine to a -10. And I still have to retain my 15 here. It's a positive 15, and I can put this plus sign out in front of it if I want to. And now if I'm combining what I have left here, I have -15 plus a -10. I had to carry this plus sign down too. A -15 plus a -10, which is going to give me a 5. So I would also end up with my 5/12. So if this way is the way that you need to solve it, if you like algebraic addition, especially if you've been an Abeka guy or Abeka gal all the way through, you might like this better. Teaching textbooks uses this some. Saxon's kind of on the fence about it. But if you like that better, fine. If you like the timeline better, fine. Or the number line, rather. If going back to my little number line theory, like if I was just looking at this part first, then minus -6 plus 15, and I was on a number line, and let's say this was 0, and this is 15, and this is -15. It's a really ugly number line. I apologize. My -6 is going to be somewhere about right here. So if I have -6 and then I have a plus sign means I'm going to go this way. So I literally would just count 1, 2, 3, 4, 5, 6, and I would just keep going, and I would literally land wherever 9 is. And that's where I would land. And then now it says -4. So a minus sign or subtraction sign means I need to go backwards. I've lost something. And then I would just bounce back until I landed on my 5. This is a really ugly number line, so hopefully it doesn't mess you up too much. But the final answer for 1.7, number 46, is 5/12. There you go. There's that one. Okay, let's move on to 1.8. 1.8, I am going to solve a handful. And I'm sorry these videos are going so long, but I want to help you with your test. And so it's worth your time for watching them. And if you watch them, it's going to pay off in your test. And we'll know. Okay, number 11. A couple of you actually wrote down on your homework that I was going to solve. No, I put something like I'll show in video. And I just want to show you this one. Super simple. 2/3 x plus 3/4 x. Okay, so it says 2/3 times something plus 3/4 times something. But I don't know what the something is. It's an unknown, and all I'm doing is simplifying this expression. So the only thing I can actually do is an addition problem. And if you remember, we just talked about adding up fractions, and we said, well, hey, if you're going to do that, you have to have a like denominator. Well, between 3 and 4, the number that can be divisible by both of those is the number 12, which makes for a handy common denominator between, if I said like denominator, I meant common denominator, but that's a great common denominator between 3 and 4. But remember, whatever you multiply the bottom by to get to 12, which happens to be 4, you also have to multiply the top by. So 3 times 4 is 12, and 2 times 4 is 8. So 8/12 is the same as 2/3. And then 4, we did a times 3. Here, 4 times 3 is 12. So we have to do a times 3 for this one. And 9 times 3 times 3 is 9. Okay, so now I can literally just add them across. I want to go ahead and throw my little x's back on here. I don't know what x is, so I can't do anything with x. I can just literally simplify, which is what it's asking me to do. So 8 plus 9 is 17. And remember, when we're doing an addition problem, we actually do something with the numerator, but the denominator just stays common. It's just a common denominator. So it just literally gets taken over here, and I'll leave my x. So my answer for number 11 is just 17/12 times x, and I just leave that alone. So that's that one. Let me do 1.8. I am still on. Now I'm still on less than 1.8. I'm going to do number 23. Number 23 is on page 34. And number 23 has a negative sign and then a bracket, a negative x plus y in the little parentheses. And then we close it back up with a bracket. Okay, please excuse my dear Aunt Sally. If you don't know it, you have to know it. You just have to. I'm going to start here on the inside. Okay, so I have x plus y. There were several different problems like this where you had to get rid of the parentheses and you need to jailbreak the parentheses. This is what I call it. Okay, you have to get them free, but x and y, they're not like terms. You cannot combine them. You cannot possibly come up with what they are worth because we don't know. So we have to just use the distributive property. Now this negative sign tells me that it's a -1. So I need to distribute this -1 to the x and then distribute this -1 to the y. This is the only way to get rid of this parentheses. So -1 times x is negative x because anything times 1 is itself. This x is a positive. So a positive times a negative is a negative. Okay. -1 times positive y. Anything times 1 is itself, and a negative times a positive is a negative. I'm going to go ahead and put my brackets back out here and copy down this other negative. Okay, so I still have a parenthesis situation here. Brackets, parentheses, braces, whatever. Still a parentheses. I'm still literally on this step. Well, I can't combine a negative x and a negative y, so I'm going to have to jailbreak it. I have to get it out of this parentheses or bracket. And again, there's this -1 here. There's a negative sign, so there's this invisible 1. Okay, I'm going to have to distribute here. -1 times negative x. Anything times 1 is just itself, and a negative times a negative is a positive. So I just have an x. Okay, let's distribute on out this way. -1 times negative y. Anything times itself is just itself. Or anything times 1 is just itself. Negative times a negative is a positive y. And if you want to put a positive sign in front of the x, you can. It's assumed. So no one usually puts the positive in the front. But you can if you want to. Doesn't matter. So your final answer is just x plus y. So there you go. That's how you solve that one. Let's do number 25. I should definitely use a brighter color. It's hard to see that one. So 25, I'm also on page 34. And this says x minus 4x plus y. Okay. Please excuse my dear Aunt Sally says, I have to start with the parentheses, but I have these two terms and they're not alike. 4x plus y, I can't do anything with this. So I'm going to have to jailbreak out this parentheses. Remember, I have an invisible 1 here. So I have a -1 that I'm dealing with. And I'm going to use the distributive property, this -1 to everything that's inside the parentheses. So if I'm feeling frisky, I could just go ahead and copy this x down, get it out of my way so I don't think that it's part of this step because it isn't. -1 times a positive 4x. Okay, anything times 1 is itself. A negative times an assumed positive is a negative because negative times positive is negative. So I have a -4x. And then when I distribute this one, I have a -1 times a y. Anything times 1 is itself. So I'm going to have a y. But I'm going to have a negative y because a negative times a positive is a negative. Okay. So I've got some subtraction problems. Please excuse my dear Aunt Sally dropped me all the way to 2 easy subtraction problems. And I do have some like terms. Look, I have something in common. I have 1x. Right? There's an x here, so it's just one of them. And I have a -4x. or I could say 1x minus 4x. Either way, these are going to combine. These like terms are going to combine to a negative 3x. Now I'm just going to copy down my subtraction sign and my y. I'm going to work left to right, but x and y are different. They're not like terms, so I'm really stuck. I can't really do anything else with it. This is just where my problem simplifies to, and I'm finished with number 25. Okay, I'm going to do one more, number 27, and then I'll be finished with my review. Thank you for hanging in here for me. Okay, number 27 is also on page 34. 27 is a big boy problem, so I'm just going to clear it all out and give myself plenty of room to do 27. Okay, 7a squared minus 4a squared plus 2ab. Lots of unlikes here. Minus 3ab. Okay. Now, so I can do it a couple of ways here. I could clean up what's inside my parentheses first, or I could distribute. I think let's just stay true to the order of please excuse my dear Aunt Sally, and that's starting with parentheses. Now, if you look at my parentheses, I've got some tricky things going on here. I have a 4a squared, and then I have 2ab and negative 3ab. Well, I can't do anything. I can't combine things that are not alike. So the only thing that's alike is this 2ab minus 3ab. That's all I really have that's in common that I can do anything with. So I'm just going to go ahead and copy everything else down so that I just take care of all this business. I have a 4a squared, and the only thing I combine now is this positive 2ab minus 3ab, which means I end up with a negative ab and end up with a negative 1ab. There's only one of those left. I could put the 1 sign in there, but it's just assumed because I have the ab. So hopefully, I'll just do a sidebar. Hopefully this makes sense to you, that if I have a 2ab and a negative 3ab, if I want to use the algebraic addition, and I would rewrite it to say 2ab plus, and I put my negative 3ab in parentheses, and I'd say, okay, I have to combine those, and if I have a positive 3, if I have a negative 3 and a positive 2, that's going to end up with a negative 1ab, which is what I ended up with right here. I just didn't show my 1. Okay, so now going back to my parentheses, these are not like terms. A squared and whatever a times b isn't like. I can't do anything with it. I can't get rid of the parentheses. I have no choice again but to distribute. Remember, there's an invisible 1 here, so I'm going to distribute, multiply this by the first term, and then I'll multiply it by the second term. So let's do this math. I'll copy down my 7a squared. Now, negative 1 times a positive 4a squared. Anything times 1 is just itself, so I'm dealing with a 4a squared. But now it's going to be negative because a negative times a positive is a negative. Okay, and then I'm going to do this one. So negative ab times a negative 1, anything multiplied by 1 is just itself, so I have an ab, and I have a negative times a negative, so now I get to have a positive. A negative times a negative is a positive, so I get a positive ab. Okay, I just have a subtraction and addition problem. I'm like pretty much to the end here, and if you notice, I only have 2 terms that are like. I have 4a squared, kind of really sloppy, but anyhow, it's 4a squared. 7a squared, my bad, this is a 7a squared minus a 4a squared, which leaves me with just a 3a squared. And then I can't do anything with this ab besides just simply copying it down because that's what's left. It's not alike. It's not like an a squared. It's something totally different. So I can't combine it. My directions just said simplify. This is my final answer. Okay, folks, I solved a couple of extra problems for you. I just wanted you to see this process. You're going to have problems just like this on your test. So it's important that you be able to solve them efficiently now. Okay, time to start this week's work.